Welcome to virtual GED class. We are in Math 144 Club mixed review for students who just need that little extra push to be ready for the GED. Today, we are going to be mixing up all the geometry you might see on the GED. So super good news. Just about every geometry problem that appears on the test is on the formula sheet. So today, as we work, make sure you have your GED formula sheet. And you might say, Kate, I don't have a GED formula sheet. Easily remedied, you guys. Google GED formula sheet, and it's the first thing that pops up, okay? It's totally available, and you'll have it with you when you go to take the test. You'll also want your GED calculator. Whenever you have a geometry problem on the test, you'll get both the calculator and the formula sheet. So you don't need to memorize how to do these things. Rather, you need to be looking out for those GED-style tricks and reasoning problems. Let's get started. Okay, first question. Bob Barker wants to create a 300 square foot patio for entertaining. If the patio is to be 20 feet long along the side of his house, how wide will it have to be? As usual, my question is, what are they asking me to do or to find?
The area?
You know, I agree that area is definitely involved in this problem.
How wide will it be?
Absolutely, there we go. They did say that we have a 300 square foot patio. The fact that they use square foot gave me a really big hint that this was area. However, we already know the area, don't we, Manal? What we're actually looking for is what Alicia just pointed out, how wide it will be. So we know the area, that's what we've been given, and we're looking for the width of this patio. Now, I've seen students use all different methods to tackle a simple problem like this. I'm not going to say we have to do it one way or the other. So let me just ask you, what are you guys thinking? Where shall we start? What do you think?
Is this where you just have to find the missing dimension?
We've got area and we're trying to find a missing dimension. Stephen, what would you do in a case like this?
I guess you could still use the formula.
You sure could. That's my favorite way. That's a math teacher's favorite way. I would still use the formula. So what formula would you go for?
I guess since you already know the area, is it area equals length times the width?
Absolutely. That's the area of a rectangle formula you're talking about, Stephen. And it is area equals length times width. And if you're like Stephen and you have it memorized, good for you. But you don't have to have it memorized. It's on the GED formula sheet. You just have to be able to find it. Now, what? I busted out the formula. What should I do now?
We plug the numbers.
Absolutely. We do what's known as the substitution step when we plug in any known values. So what do we know, you guys?
The 300 is the area.
Beautiful. The 300 is the area. And even though they didn't say it was the area, Manal knows that because they said it was 300 square feet. Area is always measured in square units. Wonderful. So I'll plug in 300 underneath that A. Where that A used to be, we'll now see a 300. What else do we know?
The length, 20.
Beautiful. They tell us that the length, the patio is going to be 20 feet long. So we know that the length is 20. Now, of course, we don't know W. How wide will it be? That's what we're solving for. In algebra, when we don't know something, we use a letter to stand in for the mystery number. Beautiful. And now we're left with a really simple little equation. 300 is equal to 20W. And using a formula, now we're relying on our algebra skills. Anybody, what would I do with something like this?
We divide.
Absolutely. I want to get W all by itself on one side of the equal sign. So I'm going to divide away that multiplier of 20. I can do whatever I want as long as I do it to both sides. And I keep that nice balanced change like I always do with an equation. And now you can see why I always cover algebra before I cover geometry. It's the same skills we were using 2 weeks ago when we did our algebra class. So multiplying and dividing by 20 cancel, W's alone just like I wanted, and you can totally do that math in a calculator. 300 divided by 20 is?
15.
15. Easy problem. We don't even have to round. We got a nice gorgeous answer, but I would like a unit in my answer. This is 15 what?
Feet square.
Ooh, careful. Area is measured in square units, but dimensions are always linear. Dimensions are lines. The width, the length, the height, the radius, the diameter, all those dimensions are lines. So this won't be 15 square feet, it'll be 15 plain old regular feet. So I'm going to make a note of that because a lot of people struggle with that. They just see area in the problem and they think all our units should be square feet, right? But it's only the area that's in square feet. Dimensions are always linear because they're lines. The length and the width of a rectangle are both lines. Radius or diameter of a circle, those are also lines. And so they'll be measured in plain old linear units. So the width, that's what this W means, the width of our patio will be 15 feet. So that is the absolute simplest geometry application I've ever seen that actually shows up on the test. Okay, so there's simpler geometry problems than this that we would, work on to build our way up to a GED level. But that's about as simple as you might see on the test, which does favor complex geometry problems. They're not like that with every subject. Like counting and probability, they give simple problems. But for some reason for geometry, they like a deep understanding. And I actually think I know why. They're like, we're giving you the formula. We're giving you the calculator. So we're going to make you do some reasoning. Let's look at this next problem. Pops Parks and Play sells commercial playground equipment. The table below compares various models of merry-go-rounds offered by the company. What is the area to the nearest square foot of playground space that will be occupied by the rocket round model? What are they asking me to do or to find?
The area to the nearest square foot.
The space of rocket round model.
Absolutely. The space it occupies is the area. I did here, like the GED likes to do, and buried the information you need along with a lot of information in a table. So let's go to that table and find what we need. What do we need?
Do you need the diameter?
Yeah, well, it's the only thing I have that has to do with the measurement of that. Right. So I guess I'm going to have to use the diameter, Alicia. She's like, that's not exactly what I need. That's what we got. So we got the diameter of which one did you want to use?
Rocket round.
Rocket round. Beautiful. So that is what we know. We are looking to find the area, and currently we know the diameter of the rocket round. If you look at the rocket round, it's got a diameter. So diameter stretches through the center from edge to edge of 7.5 feet. Beautiful. How would we attack this problem?
We use the formula, right?
Absolutely. When circles come up, you need a formula, you guys. Unless you're some kind of a ninja who's got circles memorized, knows exactly what to do, hit up that formula sheet. It's not like rectangles where we could have figured it out another way. Okay, so we need the formula. What formula would you like to use, Manal?
Area equal pi r squared.
Beautiful. The area of a circle formula makes sense. That's interesting though, because nowhere in this problem did I tell you that this was a circle. So help the students out at home who are like, how in the heck did they know this was a circle? What information gives me some hints that this is a circle? Diameter and radius are measurements we find on circles. That was a pretty big hint. It's a merry-go-round. Yeah, I know what a merry-go-round looks like. But that's the problem because not everybody would know what a merry-go-round is, But a merry-go-round is a toy for children. It's a circular toy and the children spin on it. So one of the problems that non-native speakers will have is we give you these word problems and you're like, what's a carousel or a Ferris wheel or a merry-go-round? That's a little rude. So yes, we've got this circle. We're going to spin around, but we want to find the area of it. So I love your formula. Now, what do we know?
We have the pi and the diameter we divided by 2. We'll get the radius.
Beautiful. Now I want to start with the first thing you said, Manal. I like them both, but let's start with the first thing. She said, we have the pi. Not in this problem, we don't have the pi, but you're right, we do have pi. If you look on your formula sheet, it says pi is approximately equal to 3.14. So it's not exactly 3.14, but close enough. So when I see pi, I can plug in 3.14. Now, Manal, I love what you said about we can take the diameter and divide by 2, because most students would do something wrong here. They would just go, hey, I have a 7.5. I'm going to plug the 7.5 in right there. But you're right. That 7.5 is not a radius. I need a radius for the formula. It's a diameter. So Manal must know that radius only goes halfway across a circle. So to find the radius, I could divide by 2. Now, a lot of students would struggle to divide with fractions. Anybody know how to do that? An easy way? Alicia, you're shaking your head. Is that one of the kinds of things that intimidates you?
Yes, very much.
Yeah, a lot of people get, as soon as they see a fraction, they just lose their snot. It's like everything we ever learned just flies out the window.
You just convert it to a decimal, like if it's 7.5, you just divide
that
it.
would be a really easy way to go. If you know that a half is the same as 0.5, it's way easier to do 7.5 divided by 2. Easier in your calculator, easier by hand. I'm going to do it with my calculator because I need to save my brain power for the mathematical reasoning, you guys. And I find out that that radius would be 3.75. If you know no other decimals to fraction conversions, make sure you know that 1/2 is 0.5. 1/4 is 0.25. Of course it is. A quarter is worth 25 cents. And 3/4 is 0.75. Again, of course it is. 3/4 is 75 cents. That's 90% of the fractions that come up. So you won't have to do hard math in those cases. I plugged in my 3.14, and then I'm going to plug in my correct radius, not this lie over here like some students would do, of 3.75. And I'm going to make sure that's getting squared, and all of that is equal to the area. And now that you've got that lovely substitution in, great news this time. No letters over here on the right. You can just pick up your TI and simplify. So you guys are just as lucky as can be. You get this TI while you're taking the majority of your test, but it's only going to help you if you know how to use it. So let's look at how to type that expression into our calculator. You're going to type it in exactly the way we wrote it on our page. So we wrote 3.14. So type in 3.14. And then I recommend that when they use parentheses to times, you use parentheses to times. Because even though parentheses and the times sign are similar, they're not exactly the same. Times can only multiply the times sign. A parentheses can multiply and group. So I'm going to use that one. Wouldn't make that big of a difference in this problem, but in some of them it really would. And I put 3.75 there and close the parentheses before I hit the x squared button. That's one way to get a square on my calculator. You see it over there, middle of the screen to the left. Once you hit that, you go ahead and hit enter and you'll see just what Manal saw. It is 44.15625. Am I done? I need to round. There were rounding directions in the problem, and I need the unit. Let's work with you one at a time. I need to round to what?
Square foot.
To the nearest square foot. Square foot is a whole unit, so make sure you're going to the nearest whole place. We're going to round right at the decimal. If we round at that decimal right there, throw away that one's not big enough to matter. We're going to call it 44 only. And we need a unit. 44 what?
It's square.
Absolutely. It must be square units because this time we were finding the area. Area is always measured in square units. Glorious. They're going to need about 44 square feet of space for that piece of playground equipment. A whole lot of space, actually. This problem is geometry, and problems like this will be covered in the circles lesson of the crash course. But like Manal said to me earlier today, they like to combine things on the GED, don't they? Yeah, they sure do. Here we have a word problem combined with circles, combined with reading a table. Lots of skills all in one place. Next one. Baseballs are constructed by layering a cork center with rubber and wound yarn, then covering the resultant ball in cowhide. A baseball is generally 75 millimeters in diameter. How much cowhide to the nearest square millimeter is needed to cover a standard baseball? What in the world? What are they asking me to do or to find?
This is how much cowhide.
Area.
So
Beautiful. So both Stephen and Manal are right. The problem says how much cowhide, but of course, if you look at that GED formula sheet, there's no formula for the cowhide on a baseball. A baseball is a sphere. We could find two things in a sphere. We could find the volume or the surface area. So what told you this was surface area and not volume?
Because it's covering.
Covering. That's a really good clue. This cowhide is covering the outside of that 3D shape. A covering is surface area, like we were talking about wrapping paper with Alicia earlier. Volume is filling. If I was talking about how much to fill that baseball. Beautiful. One more clue that this is surface area. I'm also looking at this. We want our answer to the nearest square millimeter. There it comes again, Leisha. Anytime you got to have that. Oh, I see square units. I think area. I need that ingrained in you because they love to hide area and surface area problems. So a couple of clues that I'm talking about surface area. I don't care which one you notice, but you need to notice one of them so you know what's going on. Obviously, there's no surface area of a ball formula. So which one should we use? What's the proper name of this three-dimensional solid?
is it a sphere?
It's a sphere. Beautiful. Cool. So bust out the surface area of a sphere formula for me, you guys.
Surface area equal 4 pi r squared.
The surface area is equal to 4 pi r squared. We got the proper formula. Now it's time to do the substitution step. to plug in what we know. So what do we know?
We have the 4 and we have the pi, but the radius, no. They give us the diameter.
Beautiful. We have the 4 and we have the pi, like Manal said on our formula sheet, it tells us pi is approximately 3.14. But once again, they did it. It's like I really want you to remember that. It's like I put that trick in every problem. We need the radius and they gave us the diameter. Rude. So yeah, it's a sphere, but the same thing applies. Diameter goes all the way across, cutting through that circle, and we want the radius, which only goes halfway across. So what would the radius be?
37.5.
37.5. So I'm going to plug that 37.5 in for my radius. 37.5 squared, and we get a giant number. I'm super glad that happened because giant numbers happen a lot and students will doubt themselves. I get 17,662 and 5/10. Now what? Any thoughts?
Rounding.
Yes, Manal pointed out that they asked us to go to the nearest square millimeter. Again, we're looking at a whole unit, so we're going to hit it right at that decimal place. Boom, boom, boom. That 5 was big enough to matter, so we are going to round it up to 17,663, and we need a unit. What should my unit be?
Square millimeter.
Bingo, girl. So I'll use the millimeter abbreviation this time and slap a little 2 on it because I'm too lazy to spell square. A lot of students are looking at me like right now, like, really? This is all we're doing over and over again on the GED? Yeah, most of the geometry on the GED is formula sheet based, which means if you can bust out the formula, boom, bingo, all we need is our algebra skills. That's nice. That's nifty. So if you want to practice more like that, once again, we are looking at the topic of surface area and volume. Lots of tricky word problems for you to try. Let's bring it up a notch. Same formula problems, but life is about to get a little more challenging. A company wants to create cone-shaped paper drinking cups to accompany their office water dispensers. They know they want each cone to hold 85 cubic centimeters of water, and the diameter of the cone must be 6 centimeters. How tall should they make the cones to the nearest 1/10 of a centimeter? What are they asking me to do or to find?
The volume?
Volume's involved. We know the volume. Here's the volume. 85 cubic centimeters. How did I know this was the volume?
Because you told us before, it's when you are filling something.
Yes, the water is filling the cone. So that's one clue. Another clue is this time it's not square centimeters. Look at what kind of centimeters it is this time. It's cubic centimeters. As soon as we're talking 3-dimensional measurements, now we're talking about a little cube that's a centimeter by a centimeter by a centimeter. This is a cubic centimeter. And that's a really big clue that we're talking about volume. When cubic units get involved, we have volume. But the deal is we're not looking for the volume. We know it. They told us what the volume is. There it is. It's 85 cubic centimeters. So we know the volume. And what are they asking us to find?
How
See
tall
that,
they should be?
how tall that cone needs to be. So if you can picture a cone, and I'm talking about how tall it is, it would be that measurement right there. Any thoughts? How might I tackle this problem?
Yes, we use the formula of
That's
the
the formula.
volume cone.
Bingo. That's why Manal was so obsessed with volume. She knew right where I was going with this. She's like, we're going to have to use the volume formula anyway, whether you know the volume and you're finding the height, or you know the height and you're finding the volume. It's the same starting place with that beautiful formula. So what is the volume of a cone formula, you guys?
Volume equal 1/3 pi r square h.
Beautiful. So V equals, I need you to be a good secretary. I'm going to stop and scold all my lazy mathematicians out there. I am a mathematician. I am as lazy as can be. You guys have seen me multiple times not spell the word square. That's how lazy I am. But even I, as lazy as I am, will never drop that V on that left-hand side. You guys who take equations and drop off half of them and treat them like expressions cannot do the algebra you need to do for the GED. Make sure you keep both sides of that equation. Okay, now our next job is to plug in what we know. What do we know?
We know everything, the 1/3, the pi, and the r square.
Beautiful.
Which is
We
the
know the 1/3. We know that as we've been doing, pi is 3.14. And we know the r. Do we know the r? Kind of.
No,
we kind of
it's
know the r.
diameter, but we have to divide it by 2. They are giving.
I love that Manal treats this like this is easy. She's like, hello, of course. If I have the diameter of 6 meters, of course, I just divide it by 2 and I have a radius of 3 meters. And I'm glad that Manal can see that, but a lot of students can't. So let me just put out my little diagram there. So my radius then we know is 3, and I keep the square in my formula. And then what about height?
They are asking about how tall should they make the cones. So we have to
Bingo.
find the height.
Exactly. Height's the thing we're finding. Okay. And this is why I yell at you guys to not drop the left-hand side of your equation. I'm not going to be able to find a missing letter unless I have an equation. So I need another side. So what about the left-hand side, guys?
85.
Bingo. I know the volume of my cone. It says that my cone holds 85 cubic centimeters of water. That means my volume is 85. So now looking at a problem like this is a little trickier than what we had last time, because as you can see, I've got a combo of numbers and letters going on over here. So I'm going to have to use my algebra skills. Any thoughts, guys? Where shall I start?
I have no idea.
So Alicia, if you're getting overwhelmed, I'm going to give you a great rule of thumb. With algebra, just like with arithmetic, you don't have to know everything to do. You can start with something you do know how to do. So even though you don't know how to deal with everything on this right-hand side, a big chunk of it is only numbers. So let's look and examine the piece that is only numbers and just examine it all by itself. Do you see that expression? That expression is all numbers. There's no letters involved. Your calculator could do that piece. And that is why we call it simplifying. It would make this thing much simpler if all that jazz was just one number. Pick up your calculator. Let's simplify the gross part. Do you know how to type 1/3 into your calculator? I'm going to teach you a cheat way, okay?
Okay.
A fraction bar means the same as divide. Let me say that again. A fraction bar means the same as divide. So anytime you see a fraction bar, you could just type divide. That's just 1 divided by 3. And then you can type the rest of it and your life will be a lot easier. And so that whole ugly part of the expression simplifies to just 9.42. Now, as always in algebra, you need to make sure that anything you have not yet used drops. So I replaced this entire thing with 9.42, but I haven't touched the H. It's still around. The equal sign, of course, must stay steady, and the 85 is still there. And see how things just got a lot simpler for us? Don't let yourself get overwhelmed in algebra.
That made it look real simple.
And that's why simplify is called simplifying. We're about to clean this puppy up. It's gross right now. We're about to make it a whole lot simpler. So the general rule of thumb is simplify before you solve. So now I look at this. This looks a little simpler. I think I might be able to solve an equation like this. How could I solve this?
Start moving things around like your 9.42 multiplying by the 8, so you do the opposite.
Bingo. I want to isolate H, as Stephen said. He knows to do that. We use opposite operations. So if I divide by 9.42 on the right, I better divide by 9.42 on the left to keep my balance. On the right-hand side, multiplying and dividing by 9.42 are opposites, and I'll do just what Stephen wanted to do and get my H all nice and isolated. And then on the left-hand side, I get
A long, ugly number.
yeah, and they often do give you long, ugly numbers on these types of real life word problems. Don't let it stress you out. Just go looking for rounding directions. Anybody see any rounding directions?
Can you understand?
Yes, that is in the 10th place. So I'm going to cut it off right after that 0.
That
Look,
is weak, so it will become 9 is the high.
yeah, I'm actually going to call it 9.0. Now, it's not that big of a deal if you drop the 0, because as you guys know, 9 means the same as 9.0. But I'm a mathematician who chooses her symbols wisely, and I know that if I leave that 0.0 around, that is a communication to all the other mathematicians that this number is accurate to the 10th place. So that's all I'm saying. I'm saying it's 9.0 accurate to the 10th place. If they said round to the 10ths, I want numbers all the way up to the 10th place. And then 9.0 what?
Centimeter.
What kind of centimeters? Plain old linear ones, square ones, or cubic ones? We were finding volume, how much to fill the space. Ooh, no. I'm a liar. Ooh, guys, I was about to lead you astray. I was about to lead you astray. Did you hear what I just said? I said we're finding volume. Guys, did we just find volume?
No.
No, we found the Height. Kate, pay attention. We talked about this on the very first problem of the day today. I must be getting tired because even though volume is a three-dimensional measurement, the height is just a line on this three-dimensional shape. So this is just plain old centimeters right now because all I found was the height. This is geometry, and this is as challenging as those formula problems get. We're finding missing dimensions algebraically this time. We are going to have a lot of algebra skills to solve these multi-step equations that come up when we do this. Let's try another. A specialty popcorn shop, Pop, is creating packaging for its new holiday offering, peppermint mocha mint drizzle corn. They know that they want each cylindrical package to be 20 centimeters tall and to hold 1,000 cubic centimeters of popcorn. What should the radius of the package be to the nearest tenth of a centimeter? What are they asking me to do or to find?
Radius.
We're looking for the radius. And we know that the radius has something to do with the circle. The radius goes halfway across a circle, but we're not looking at a circle because we're trying to package something. What is the shape of this thing we're trying to package?
Cylindrical.
Cylinder, wonderful. Of course, circles get involved because cylinders have circular bases. But there we go, we got our nice cylinder shape and we're looking for the radius. Any thoughts? Where shall I start?
Formula.
Alicia's like, I'm getting this. I'm getting
Finally
this.
getting it.
Absolutely, girl. Hit up that formula sheet. And once again, whenever we have a three-dimensional shape, we're going to have a choice, surface area or volume. So which formula should I use?
Volume.
Volume. What in this problem told you it was volume, Manal?
It says hold.
We're looking at how much popcorn it's going to hold. It's going to hold 1,000 cubic centimeters of popcorn. So that's one clue. The fact that it's holding that, it's getting stuffed inside the package. Yeah, volume is a filling. And then one more clue. Did you guys notice the unit on that number? It says we're going to hold 1,000 cubic centimeters. There we go again with the cubic units. Anytime you look at a cubic unit, a three-dimensional unit, now we're in the world of volume. For those of us who aren't like Manal, that it just pops into our head, there's the clues we can use to know that we're looking at a volume of a cylinder and not surface area. Beautiful. So what is the correct formula I should choose here? Volume equals pi r squared times h, or V equals pi r squared h. I've got the formula down. My next step, of course, like we've been doing over and over again, like it's just the same dang skill, is substitution. Let's plug in what we know. So what do we know?
We know the height and
We know
the pi.
Beautiful. Beautiful. We know the volume. It said that that was 1,000 cubic centimeters of popcorn. That's a cubic unit, so that must be the volume. Equal signs don't change. The formula sheet says pi is about 3.14. We'll plug that in. And we know the height, but we got a problem. We don't know r. So I'm just going to drop down my r squared and put my height over here. Oh, what did we say their height was? There we go, 20 centimeters tall. How tall it is the height. This one looks a lot like the last one, but this one tends to intimidate students more because the numbers are not together in a chunk. They don't know how to simplify it, to make it any simpler. And there's actually more than one right thing I can do right now. There's not one right way to go. So let me ask you guys what you think. Do you see something you could do?
3.14 times 20.
Beautiful. Manal knows that when multiple numbers are multiplying, and that's what's going on here. 3.14 is multiplying with r squared, which is multiplying with 20. When we have a lot of numbers multiplying, we can multiply in any order we want. We really can. So if you want to do that to be a lazy person and make your life simpler and put the numbers together, you're allowed to do that. And I'm going to go ahead and do that. And it only works because all three of those numbers are multiplying, okay? If there were different operations going on, I couldn't do this. But they're all three just multiplying. And so I can multiply in any order I want. Sure. Let's multiply 3.14 and 20. 62.8. Now I used up this piece and this piece, but I haven't touched the r squared. So make sure it drops and I haven't touched the 1,000, so make sure it drops. So this thing just got a little simpler. Now be careful, guys. A lot of students would want to try to square this number. That square is not on the 62.8. That square is on the R. I cannot make this side any simpler. I can't square R because I don't know what R is. I can't multiply R squared by 62.8 because again, I don't know what R is. I am done with simplifying. It is time to start solving. It's time to start doing the work to get R alone. Your algebra skills have got to kick in now, guys. Any thoughts? How could I isolate R? How could I get it alone?
Divided.
Bingo, Alicia. Yes, girl. That 62.8 is just a multiplier. You want to get it out of here, divide it away. Bingo. Now, I'm literally changing. I'm doing the opposite of what I was told. I'm a little rebel. I can do that as long as I do it to both sides. As long as you keep an equation balanced, you can literally do whatever you want. So let's look at what happens now. On this right-hand side, multiplying and dividing by 6.28 cancel, that's gone. But what's left? This entire R squared is left. Now, you're going to get a gross ugly number when you do this in your calculator. That's cool. It happens all the time in these geometry problems. 1,000 divided by 62.8 is this gross, long, nasty thing. I'm not going to write it all down, but I am going to leave it all in my calculator. Make sure you don't round until the end. Now, I got all these students who say to me, Kate, isn't it the end? Aren't we done? Yeah, don't be that student. We're not done. What do we still need to do to solve this problem, to get R by itself?
Make roots.
There we go. We've got a square to get rid of. The opposite of square is square root. In order for R to be really, truly, totally alone and isolated, I've got to do the opposite of square, which is square root. And of course, we can do whatever we want as long as we do it to both sides. Okay, so on the right-hand side, that's easy to see. Square and square root cancel, so R is alone. On the left-hand side, this is some computer work to do. To get the square root of this number, it is a green key. So we have to hit that second green button. And then we can get the square root symbol by pressing that X squared button. The square and square root are opposites. So we use the same button, but just we use hit that green key first. And then use your arrow key to arrow up to that long number so you don't have to type it back in and you don't lose any data. Press enter to select it, enter again, and you should get 3.9904, yada, 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 ugly, ugly, nasty number. So am I done?
No, you have to round it.
Thank you. I have to round it. Where did they want me to round to?
The nearest tenth.
The nearest tenth. Careful, guys. A lot of students who round to the nearest tenth actually think they're rounding to the nearest tenth, actually round to the nearest unit. So if I want it rounded to the nearest tenth, I want my number to end right there. So I'm going to consider the next place, the hundredths place. Big enough to matter, you guys?
Yeah.
Absolutely. So I'm going to round that number up. After 3.9, if I'm counting by tenths, the next number up is 4.0. Once again, I'm going to keep that 0 around to signal to everybody my number is accurate to the tenths place. So 4.0 what? This one's just regular centimeters. Anybody want to tell me why it's just regular centimeters and not cubic centimeters?
Because we are finding the radius. Not
Yeah, beautiful. The radius is just a line. It's going to be plain old centimeters. And is that what they asked us for? Yeah, they asked us for the radius. We found the radius. Sweet, good to go. I just had to make sure they didn't ask us for the diameter. Sometimes these problems have an extra step where you have to go from radius to diameter. Again, this is the topic of geometry. This is finding missing dimensions algebraically. And I love my GED students, but y'all often do not go deep enough in geometry. You guys study all the geometry and how to work all the formulas forwards, and then when you get this style, which is their favorite on the GED, where you have to work backwards and use your algebra skills with your geometry skills, you just panic. So make sure that you're at this level of depth before you take that test, okay, you guys? That's my mama advice for you. I mean, teacher advice, but I think I'm everybody's mom too. Okay, let's move on to something new. We're sick of formulas, right? The shape below is composed of rectangles. What is the perimeter of the composite shape? I got a lot of students who say, Kate, this is too a formula problem. Perimeters on the GED formula sheet. And I say, you're right. The second section down says perimeter, but good luck finding this shape in the list. And so I am not going to hit the formula sheet this time. This time I want to do it with definition. Guys, what is the perimeter?
Add all the sides.
Okay, Manal knows how to find it, but what is perimeter?
The measurement for the whole thing.
Okay, the whole what thing? There's two ways I could measure this shape. I could cover it, or I could go around it. Around it. Bingo. The perimeter is the measurement or distance around a shape. Now, I like what Manal said, because based on knowing this, the measurement or distance around the shape, Manal told us a really easy way to find it. She says, you know, if you just want to go around the shape, just add up all the sides. And I absolutely agree with you. The simple way to find the perimeter of any given shape, you don't need a formula, is just to add up all the sides. So it looks super easy, and a lot of students get excited. They see these sides, they start adding, they go, woohoo, I'm done. And they get a wrong answer, because it is important that you add up all the sides. I cannot stress enough that you need to add up all the sides. And this is a reasoning test. They are going to make sure that they leave off a side, you guys, or maybe two, or possibly even three. Okay, so make sure that you know all your sides before you start adding. Can you see on this guy that I have a missing side? It does not have a dimension. They left off a side. Uh-oh. I need to know how long that side is before I can add up all the sides. So any thoughts?
If you look right below, you see the 12 inches and the 7 inches. That's how you can kind of figure out.
Yes, we're going to use that as well as the 27 inches. What Stephen knows is that the opposite sides of rectangles have the same length. Now, even though this whole thing isn't a rectangle, it's composed of rectangles. I can break it into rectangles. So if this side is 12, then over here is 12. And if this side is 7, then over here is 7. So I can use that information to find this missing piece right here. Then how long would that piece be? Alicia, what are you thinking? 8 inches, girl. Where'd you get that number?
Well, what I did was 27 minus 12 minus 7.
Beautiful. Alicia knew if the whole length is 27 and I take off that 12-inch piece I don't need and that other 7-inch piece I don't need, remove them out of the 27 inches, I'll have the remaining length. So 27 minus 12, and see how we needed those math reasoning skills. And she's right, that piece is 8 inches, which means this piece is also 8 inches. Nice job. Are you a visual learner, Alicia? She's like, yeah, picture. Yes, girl, yes. I'm not a visual learner. If we were going to explain this my way, like I was talking to a bunch of people that thought like me, I would just be words, 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 words. So that's why it's so important to have multiple representations, because Alicia likes a picture. Manal likes a formula. Kate likes words all over the dang place. Okay. Yes. We all think about this differently, and none of us is wrong. I don't care whose logic you use. You just got to use good logic. So now we can add up all the sides. We got them all right. We got an 8-inch side. Oh, we don't have them all.
We don't?
No. And do you know, I'm so glad. Let me erase all this messy because it got really messy. I'm so glad that, right. Yeah, you see it?
Side right there.
Yeah, that little bitty side. And the only reason I even noticed is because I always visually go around it when I do perimeter. I go in order 8, and then I visually went down this line with my eyeballs and said, oh crap. Okay, so we have another missing piece. Any thoughts, guys? Ooh, is this a hard one?
Yeah, it is tricky.
So when I get a tricky one, I'm going to outline every line that's going in the same direction. So you see how this one's going up and down? Any other line going up and down could contribute to this. So this one's going up and down. This is useful. This one's going up and down.
Oh, I know.
What do you know, girl?
11 minus 7.
11 minus 7.
No, wait, maybe I'm wrong. No, I'm wrong. Because I'm looking at
Let me think about that, because I think a lot of students would do that. So let me think about why I would not do 11 minus 7. Oh, I know. It's because 7 is running in the opposite direction.
Yes.
It's going left, right instead of up, down. It doesn't come into play right now. Good. Okay, so that's not going to work. So it's, This is a reasoning test. So if we come up with some reasoning, we just got to test our reasoning, you know, did that work? So, you know, it's hard because these sides don't exactly line up, but here's what I do know. I want you to imagine that this was already all drawn out. So this whole side and this whole side would have to be equal. That's the one thing I know, because none of the other rectangles line up this way. Can you help me find a total? Can you help me find that whole side? We just talked about that whole side. How much would that whole side have to be? Nice. Andrea says on this side over here on the left, I can see they're both labeled. 12 plus 11 would be that entire length. This entire length is 23 inches.
The other side is 6.
You say 6 inches. Andrea, I agree. Where'd that 6 come from?
Because 23 take away the 17.
Absolutely. That whole length is 23. Take away the 17 piece I don't need, and I get 23 minus 17, or just 6 inches. Cool. Woo, I almost got tricked just because I wasn't paying attention. Okay, now we can go all the way around. Dear Lord, I hope so. Let me just clean this sucker up a little bit. Okay, so I have an 8-inch side, and a 6-inch side, and a 7-inch side, and a 17-inch side. And some of you guys are going like, why is she going so slowly? It's because one of the biggest mistakes students make is forgetting a side. So I just want to make sure I trace every side and I get all the way around my shape. Yep, and yep, I see you guys picking up your calculators. I would too. I don't have time. I got to use all my brain power for math reasoning. I am not trying to do computations by hand right now.
100.
Beautiful. 100 what?
Inches.
Plain old regular inches. Even though perimeter is a little complicated, it's still just moving in a line. It's a linear measurement. It's a line with corners on it, but it's a line. And so it's 100 plain old regular linear inches. My class is always divided directly in half. This is one of the days where half the class is bored out of their gourds. Like, it's so easy. Why can't they see it? And then the other half is like, how'd you get those missing sides? I don't understand. So if you are not a visual learner, I am not. It is going to take some practice to learn to be good at finding these missing sides. And I need you not to feel bad. Just because Alicia's a natural at it doesn't mean you need to be. Okay, so go dig into this on the crash course. It is perimeter of composite shapes. And I have some very tricky examples where using those colors like I did to find those missing sides can really help you.
I think I was okay on the left side, but I think I got thrown off on the right.
Yeah, it was hard. And that might even be a harder example than what you see on the GED. You might see a lot on the GED that line up like the 8 did. So I don't know if it'll get that complicated, but I certainly want you guys to have those reasoning skills to have a shot if it does. Okay, a high school's racetrack is pictured below. To the nearest meter, how far would a runner travel in 1 lap around the track? What are they asking me to do or to find?
Find the nearest meter, how far a runner will travel.
Okay, and nicely we have this picture. So here I am, a little runner, and I'm gonna run around this track. Well, how far would I travel? I would travel around the track. I would travel that far, except for y'all know I wouldn't run. But okay, if I was a runner, that's how far I would travel. How far is that? Any thoughts?
440 meter.
Well, there's definitely a 440 going on, isn't there? We have a piece of this that's 440 meters, okay? Now, careful. Ooh, I probably should have put lines here so that it was clear. They would definitely have it be clear on the GED. So let me add this in as if this was always there. When this is labeled 440, I'm talking this side from here to here.
Do we add everything like 440 plus 110 plus 440 plus 110?
We add everything the runner runs, Alicia. Right. So I agree with you that the runner runs this 440 meters. On that straight stretch there, he does. And he runs this 440 meters. But the runner's gonna be disqualified if he runs the 110. Running the 110 is cutting across the field.
Right, he's going around, gotcha.
So dude's not gonna hit that 110. He's gonna do the path here and the path there. Now we got a little weird. that's not a marked number. It's not a known number where he's running there. We're going to have to use our math reasoning skills to figure out those pieces. Once again, just like before with the rectangles, we had to use some math reasoning skills. Again, here with these shapes, we're going to need some math reasoning skills. So any thoughts? What am I looking at? What is that shape there?
Circumference of a circle. No.
There we go. We are talking about circles. Yes, it's only a part of a circle, but we're going around a circular shape. We need to use the circumference of a circle formula. Now, this is obviously not a full circle. This is part of a circle. You can imagine you had a circle. Okay, like how much of that circle do we
half
have?
of it?
It's a half of it. Bingo. Yeah. So now this is really nice because if we have a half of it over here and a half of it over there, you know, put those together, we're looking at a whole circle. But yeah, well, let me just look at one piece at a time to go with most students' reasoning here. This is a half of a circle. So if I wanted to, I could, you know, just find the circumference of a circle, like imagine go all the way across and then just half it. Let's do that. So circumference of a circle. How could I find the circumference of a circle?
Use the formula.
Thank you. Circles come up, you hit the formula sheet. Circumference of a circle, and there are actually some options. You're gonna see two formulas. You're gonna see circumference is equal to 2 pi r, or circumference is equal to pi d.
We use the pi d.
Manal, why'd you choose to use the pi d?
Because we already have the diameter.
Because we know the diameter. This line 110 goes all the way across a circle. That line 110 is the diameter of a circle. So the circumference is going to be 3.14 times that 110. Let's see, 345.4. You would not have been able to come up with that number mathematically. You have to, unless you knew the formula or knew the steps of the formula without having the formula memorized. But one way or another, you have to know how to find the circumference of the circle. That being said, careful. We just want this piece right here. This formula is the circumference for a full circle. So if I want to get just that piece, I'm going to have to half it. I'm going to half it the quick way by dividing it into 2 equal pieces. If I divide that sucker by 2, this piece is 172.7. This piece is also 172.7. Now, if you're thinking, Kate, I wouldn't divide it in half. I'd just use it once. That's fine. You could do that too. But just don't write 2 345s like some students do. Some students tell me this one's 345 and that one's 345, and then they're wrong. So now I have all the lengths that my runner is going to run measured out. I know how long they all are. So I can find the total distance he's running. How could I find the total distance he's running, you guys?
Add.
Add, absolutely. He's going to run 440 meters. And then he's going to run 172.7 meters. And then he's going to run another 440. And then he's going to run that last stretch of 172.7, and then he's going to be exhausted, I bet, which is why I'd rather go shopping. So I get 1,225.4. Am I done?
No, round.
Beautiful. They did give me some rounding directions, didn't they? What did they say to round to?
Nearest meter.
Mm-hmm. Which means what?
I guess we got the whole number. Because
yes, absolutely. That's the nearest whole meter. We're going to cut it off right at the decimal place. Not big enough to matter. And so I'll call that 1,225 meters. Dude is not running in square meters, okay? He does not run across the field like this. It is a line he runs in. Yeah, it's a big, long, round line, but it's still a line. 1,225 meters. So you want to practice this. Again, we're looking perimeter of a composite shape. You're going to find some shapes with some circular pieces on the experienced and advanced level practice on the crash course. Don't panic. Here we go. A circle is inscribed in a square with a 6-inch side length as shown in the diagram well to the right. Find the area to the nearest tenth of a square inch of the shaded region of the square. What are they asking me to do or to find?
The area of the shaded around the circle.
Yes, ladies. So the shaded region, this gray portion, once again, yes, area is on the formula sheet, but good luck finding the area of round-sided triangles. I don't even know what those things are. So we are going to have to use our math reasoning skills. Look at the shapes by themselves first. So let's look at the outside shape. The outermost shape is a what?
Square.
And then look at the inner shape. The inner shape is a
Circle.
gorgeous. This shaded portion is just a square with a circle cut out of it. So let's deal with those two pieces. Let's deal with the square. Let's deal with the circle. And then we can mathematically remove the circle from the square. Okay, so let's start. Let's deal with the square. We are finding the area. So let's imagine for now that this entire thing was shaded. We had just the area of this square. We would know how to do that. Any thoughts?
6 inches each side.
Each side is 6 inches. I agree with that. So if I wanted to find the area, what does that mean for us about the area?
Side times side.
Sure, a square is a type of rectangle. So we could find the area by just multiplying those two sides, side times side, 6 times 6, or 6 squared, as we often call it. But I don't care if you write it 6 squared or 6 times 6, you're still going to get an area of 36 square inches. Beautiful. So we know how much that is, but unfortunately we don't have all that, right? We are missing a piece.
But we didn't find the area of the circle.
Bingo, exactly, Manal. Let's figure out the area of that circle. How could we find the area of that circle?
Area equal pi r square.
Beautiful. Manal might have it memorized by now, but that's on the formula sheet. You don't have to have that memorized. So as Manal keeps pointing out to us, we know pi is 3.14, but how about r? How about the radius of this circle?
It would be half of the 6.
Nice job, Stephen. Let me pull out another color so everybody else can see that. If it's 6 all the way across here, it would be 6 across here in the center as well.
Stephen.
Nice. So, yup, that piece there would be 3 inches. Would you think to do that if you've never seen it done before? And especially when you're taking a test, your reasoning skills are a little cut down because you're anxious. The more anxious you are, the harder it is to use higher order reasoning. I think seeing these tricks done before your test is so important. So we're able to find the area of this circle, and then it is what?
28.26.
Good. We know the area of the larger shape, the whole big square. We know the area of our whole, that circle. So all we need to do is cut the whole out. Mathematically, how could I remove a piece?
Subtract.
Subtract. Bingo. That what goes back to the very first day of math class. Like, you know, to cut out a piece, we just subtract. That's removing a piece. So let's take that 36-inch total, subtract out that 28.26 square inch piece, and we'll have the remaining area of the shaded portion, 7.74 square inches. And you would never have gotten there without some pretty serious math reasoning.
We make now to rounding to the nearest 10.
Oh, I didn't even notice. I was about to move on. I was so proud of myself for doing the hard work, and I would have gotten it wrong for not following directions. Thank you, Manal. Manal can be my secretary any day. She's not forgetting anything. Okay, we need to round it to the nearest 10th. Where am I talking about if I talk about the 10th place?
7.
Yeah, this second 7's in the 10th place. So I'm going to cut off my number there. That's where I wanted to end.
4 is less than 5.
And Manal's right. Don't be boxing up that answer. Box up the final answer, Kate. 7.7 square inches. So this is geometry, and this has its own lesson page, area of composite shapes. Definitely check that out. Definitely practice that math reasoning before your test if you haven't already. Here we go. At hole 9, golfers have a choice to try to reach the tee in 2 strokes, first hitting the ball due north, then east to avoid the lake, or in a single stroke, straight across the lake. How far is the hole from the tee for the golfer who chooses to aim directly for the hole from the tee? What in the world? I'm not a golfer. What are they asking me to do or to find?
What is the far between the tee and the hole?
The distance, right? Between the tee, here's the tee, and the hole. Well, what's the distance? They're asking us to find that thing. Okay, so get past all that, I don't know jack about golf feeling, and just get to what's the question? I'm looking for that piece, and that's on a shape, isn't it? There's a shape here. What shape do you guys see?
Triangle.
Triangle. They're asking for a side of a triangle, and Manal just told me what kind of a triangle. What kind of a triangle is that, Manal?
Right.
A right triangle. We went due north, we went due east. We formed a right triangle. They're asking us to find the missing side of a right triangle. And notice we know some stuff. We know this side of the right triangle is 220. We know That side of the right triangle is 165. So here we are. We know two sides. We want to know the third side. Any thoughts?
I think that it's a square plus b square equals c square.
Manal knows how to find the missing side of a right triangle. There is a formula on the formula sheet that gives us the relationship between the three sides of the right triangle. It's known as the Pythagorean theorem, and it is a squared plus b squared equals c squared. Again, you don't have to have it memorized. It's on the formula sheet, but you better know when to use it. And you need to know what your A, your B, and your C are. So when you're looking at a right triangle with a right angle, the A and the B are the legs. You can recognize the legs of a right triangle because they make an L. They make an L around the right angle. Those are the legs. You might say which one's which. It don't matter, okay? A, B, whatever. Interchangeable, they're both legs. Now then, what's C? C is the hypotenuse. Directly across from the right angle, you'll find the longest side, the C, hypotenuse. Beautiful. Now that we know that, let's try to plug into our formula. A, B, C. What do we know?
The 165 yards.
165 is one of the legs. I could plug it in for A or B. It wouldn't matter. They're interchangeable. So I get B, and that's being squared. I drop my plus. What else do I know?
The 220 square.
Wonderful. Is the 220 an A or is it a C?
B-A-A.
It's an A. It's another leg. It goes around that lovely right angle. Okay, A and B are interchangeable with each other, but not with C. Make sure you get those straight. Okay, so I get that 220, that's squared. And then C is that missing side. I don't know the hypotenuse, that longest side across from my right angle. And don't forget the square on your C. So now, just like always, when you have a formula, once you plug in the numbers, it's your algebra skills that need to kick in. We aren't in geometry land anymore, Toto. It's time for some algebra skills. Any thoughts? What could I do with this equation?
We do the square one, the 220 times 220.
Absolutely. We can simplify the left-hand side. Now, you could do it one step at a time and square it if you want, or you could be super duper lazy. There's no numbers over on the left-hand side. You could plug that whole dang thing into your calculator, which is what I'm going to do because I'm so super lazy. So 220 squared plus 165 squared. I know my TI can handle the order of operations for me. I type the whole thing in and I get this big, ugly, nasty number, but at least it's a little simpler. 75,625 from this entire expression. And that is going to be equal. Now, I got way too many students who just stop right here. Also proud of themselves, Kate. I knew what formula to use. I plugged in, I simplified, and they're like, it is 75,000 feet across that lake. And I'm like, I hope you have a real strong arm. I'm not done yet. What do I still need to do to solve this problem, you guys? Square root it. Absolutely. Yeah. Square root it. So it is not alone. It has a square on it. The opposite of square is square root. I can do whatever I want as long as I do it to both sides. We need good algebra skills, but we need some good common sense skills too, you guys. 75,000 feet across the lake, we're in trouble. Okay, so once again, I'm going to pick it up and do that in my calculator by hitting the green second button. Then I can get that square root key over the x squared. And I'm so lazy, I'll probably arrow up to my original number again. Press enter twice, once to select and once to get the answer. And then Manal can tell us what it is.
275.
There we go. So I get 275 on the left-hand side. And on the right-hand side, square and square root cancel, so C is alone. Sweet. Now it's solved. Now C is isolated. So I know my C, my hypotenuse, is 275. 275 what? Oh, I keep saying feet, 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 but it ain't feet. What is it?
Yard.
Bingo. 275. That would be even crazier. 75,000 yards across the lake. So much trouble. Okay, so 275 yards across the lake. Okay, that makes sense. So this is in the geometry unit. If you want more practice, topic is the Pythagorean theorem. And yeah, it takes a little bit of practice. And I got good news. I kind of got one more. Let's take a look. Marisol is flying a kite. She has let out 42 meters of string. Her friend Calvin is standing directly underneath the kite, 27 meters away from her. How high to the nearest meter is the kite flying? Okay, what am I asking you to do or to find?
I want to know how high is the kite flying?
To the nearest
Meters.
meter.
Beautiful. And if I look at that on my diagram, how high is the kite flying? Well, you know, when you measure how high something is, you measure from the ground on up. So I'm looking at this little dotted line here. Any thoughts?
We write the formula, which is a square plus b square equals.
Manal is telling us this like it's obvious, but for a lot of people, it isn't obvious. How does Manal know to bust out the Pythagorean theorem? What clues did she have that it was time for that?
Because it's right triangle.
I got another right triangle. How do I know it's a right triangle? Well, Calvin doesn't lean when he walks, okay? Calvin stands straight up, okay? Most people do. Okay, so that's an idea that if we're coming up the height from the ground, we're looking at a nice right triangle. It's implied that things, you know, height is up and down from the ground. Okay, so yeah, definitely I've got a right triangle. I've got a missing side, but I know two other sides. That is the time for the Pythagorean theorem. Nice job, Manal.
Is there a left triangle or is always a right triangle?
No, right means 90-degree angle. That little box thing is the shape that mathematicians use to signify a 90-degree angle, but there wasn't a box in this problem. You're just supposed to know that if you're talking height, it comes straight up. Those are called right angles. Construction workers often call those squares. They square the angles, but
Yeah.
in math, we call them right angles. And Alicia, the three types of triangles are, when you're talking about angles, are acute, right, and obtuse. So not left, right, but acute, right, and obtuse. But the good news is the only one you really have to know for the GED is that right angle, and it's because of this formula. So I've got my formula. What do I know?
We plug the numbers that we have.
Yes, and most students substitute wrong here. They plug the numbers into the wrong spots. So let's be really careful. A, B, C, what do we know?
We know the B and we know the C, but A, we don't know it.
Beautiful. Now, Manal, I could have called this one A or B. It doesn't matter since they're interchangeable, but you're absolutely right. I can't call it C. This is C. C is always across from the right angle. So it's super duper important you get that 42 in the right place. And so Manal wants to call that unknown A, and then call the other one, the 27, the B. That's just fine. As long as I have the C in the right spot, I will be good to go. It's those algebra skills I need you to have kick in. You don't have to know everything to do. You just have to know the next thing to do. Just look for a piece or a part that you know how to do, not everything. Don't let yourself get overwhelmed in the symbols. Remember that general rule to simplify before you solve. If there's any piece you know how to simplify, we should start there.
So you just bring the A2 down.
Yeah, absolutely. I can't simplify the A squared because I don't know what A is. Okay, and so for the same reason, I can't do that addition.
Yes, simplify 27 to the second power.
Exactly. That's something we can make a little simpler. 27 to the second power is?
729.
Beautiful. Probably Stephen just squared that in his calculator. I don't imagine he did that one by hand. And that's equal to, how about the other side? Is there any simplifying we can do over there?
Put it in your TI, 42 to the second power, which is 1,764.
Beautiful. Good. Simplify before you start solving and you make your lives a lot easier. That algebra will start looking a lot simpler. Okay. Any thoughts now?
We subtract.
Absolutely. We're done with the simplifying. There's nothing more we can simplify. On the right-hand side is just a number. The left-hand side, I'm out of math I can do. It's time to start moving backwards. It's time to start working to get that letter alone. Manal would like me to subtract away that 729 that I can't add. And sure, I can do that as long as I do it to both sides. My new equation will be
1035.
1035 on the right-hand side and on the left-hand side.
A squared.
Absolutely. Stephen knows it's not an A. It's still an A squared. I got rid of the 729, but I haven't dealt with the square yet. And then so many students stop right there. The kite is 1,000 meters high. And I'm like, dear Lord, we're not done yet. What do I need to do now?
We do the roots.
Absolutely. And get a nasty number. Okay, great. So the opposite of square is square root. If I really want to isolate that A, get it all by itself, I got to get rid of that square. Square and square root cancel, leaving A alone just like I wanted. And Manal tells me I'm going to get a nasty number. Let's check it out. You're right. When they're not perfect, we get irrational, long, ugly, gross decimals with no pattern.
I used to write all the number because here to the nearest meter, so we just take the whole number, right?
Yes, to the nearest meter. So we just take the whole number, so I can round it right at that decimal place. And so my nearest whole meter is 32. So I'm just going to stop at 32 meters. One of the things that I don't like about the way teachers teach things is when an equation's like this, do this. When it's like that, do that. When it's like that, do that. When it's like, and then you guys are going to try to memorize all the different do this, do that. And it's like a big mushy. And so that's why I always come back to those algebra rules. I mean, the algebra rules are the same thing every time. Simplify, then solve. Simplify, then solve. I'd much rather remember that one set of rules for all the equations than a new set of rules for every set of equations. You just feel overwhelmed.
Yes.
Okay? Yeah. You want to practice this once again, hit up the Pythagorean theorem page. Have fun. Okay. Last problem. Y'all ready? I saved the hardest for last two when y'all are all brain fried. Rude. Here we go. Murad wants to blow up a 4-inch by 6-inch photo of his dog to create a framed picture for his living room. The framing store offers the size options described in the table. Which of the following sizes would be in proportion to his original photo? Choose all that apply. What are they asking me to do or to find?
Find the size.
We'll definitely have to select some sizes. So which of the following sizes? I'm selecting a sizes. But which sizes am I supposed to select? Which one did they want from us? They tell us that those following sizes should be
Proportion.
in proportion. In proportion. Let's make sure that we know what that phrase in proportion means.
It's like scaling or something.
It is exactly like scaling. Stephen, I'm so glad you said that because that's the other term they use on the GED for this. They call it scaling, where they talk about scale factors. Absolutely. So it being in proportion is scaling something. Let's talk about using a computer or using a phone. We do it all the time when we blow up images or we pull them down. We can do that on our phone, right, with our fingers. And no matter if you make the image really big or you make it really small, it stays in the same proportions. Well, sometimes when I'm having fun on my computer, I'll pull out an image so that it's not in proportion. You know, I have a nice handsome picture of my husband there. And if I just take one side of it and pull it out that way, I can make my husband look really funny, right? I can turn him super fat like Funhouse Mirror Husband. Or I could take just the top and pull it out that way, and I can make my husband real tall and skinny. I'll be like, honey, I always wanted a tall husband, and just mess with his proportions. Okay, if I did that, it would not be in proportion. So super duper important when something's in proportion, that the same rate it grows going up, it grows the same rate going out. In proportion means it grows by the same rate in both directions. Okay, wonderful. So now then, how do we think about that mathematically? Now I'll go back to Manal. Which one of these did you like, Manal?
8 times 12.
Manal liked 8 times 12. Give me some reasoning. What did you like about 8 times 12?
Because 4 times 2 is equal 8. And
Manal took that 4 inches and got twice as big this way. And she said, if I got twice as big that way with my 4 inches, I better get twice as big this way. 6 times 2 then is 12. Beautiful. That was definitely in proportion. Andrea likes 16 times 24. Okay, give me some reasoning. What do you like about 16 times 24?
I times 4 by the 4, and you know 4 by the both number 4 times 4 and 6 times 4.
Beautiful. It grew by the same ratio, 4 times as tall and 4 times as wide, and a 16 by 24. So look at you guys just spotting some that are in proportion just out of the list without even really doing any calculations or anything. Does anybody else see anything that they could think of that way?
Not sure about 2 and 3. 2 into 4, 2, 2 into 6, 3. I'm not sure, but I'm just saying.
You're not sure. Okay, so cool. So there's a couple we could just spot using our common sense. Great. But what do we do when our common sense fails us and we're not sure? We have some guesses, but we're not totally, it doesn't go so nicely. Well, guess what? If things are in proportion, they make equivalent ratios. Another word for ratio is fractions. 4 over 6 is absolutely equivalent to 8 over 12. The relationship of 4 inches and 6 inches is exactly equivalent to 8 over 12. One way I can do that is by reducing fractions. Let me show you what I mean. 4 over 6, if I reduce it by a factor of 2, gives me a relationship or ratio of 2 to 3. And so does 8 over 12. I can reduce it by a factor of 4, and it also gives me a relationship of 2 to 3. Any one of these that reduces to a relationship of 2 to 3 is equivalent. Knowing that, do you see any others that are equivalent?
Maybe 12 by 15.
Let's take a look. Let me take that relationship of 12 to 15, reduce it. Let's see, what do they have in common? They have a 3 in common. Divide by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. That's not going to reduce any further. It's close to a 2 to 3 relationship, but it isn't exact. This one did not work. So totally cool to guess it, but check your guesses by seeing if it reduces to the same thing. There is another one, though, that is in proportion.
2 times 3.
Absolutely. The 2 foot by 3 foot is just a really clear 2 to 3 relationship. I got another way. Can everybody pick up their TI for me? Now, a lot of students won't want to do this because they see a time sign on the dimensions. That's fine. I'm not asking you to find out what the area is, do 8 times 12. What I'm asking you to do is find out what the relationship is. A mathematical relationship is done in a fraction. So 8 to 12. I want you to pick up your GED calculators and I want you to divide. 8 divided by 12. The relationship of 8 divided by 12 can be converted into a decimal. What decimal do you get?
0.666.
If you don't like reducing fractions, try doing it as a decimal, okay? Same thing with the relationship of 4 to 6. 4 divided by 6 gives you what?
Same. 0.6.
Same. How about 12 divided by 15?
0.8.
Close, but not the same. How about 15 divided by 20?
0.75.
Close, but not exact. How about 16 divided by 24?
0.666.
It's the same relationship. Even though it's not the same numbers, it's the same relationship between them. It's the same ratio. I don't care which way you use, girl. It don't matter. Again, my logic is not your logic, but as long as we're using logic, we're good to go. Okay. But what you have to know is that a fraction means a relationship. Told you I saved the worst for last. Not on the formula sheet, you just have to straight understand about proportional relationships for these. And this is one of the one-offs on the GED. Like I just have one lesson on it. You don't build this skill. Whereas the formulas, we use the formula for circles, then we use it for surface area, then we use it for volume, and we use it for Pythagorean theorem. It's the same skill set, just with different formulas. So you really get a lot of reinforcement for it. But for this one, this is the only thing like this on the GED. So we don't get a ton of reinforcement for it. We just practice them one time, which means it's super easy to forget.
Whenever they are asking for proportion, it's mean that we have to find the equivalent fraction.
Yeah, yes. When things are in proportion, they form equivalent fractions. So 4/6 is in proportion to 8/12. These two things are equivalent fractions. Whereas 4/6 is not equivalent to 12/15. So these things are not in proportion. Good. I love it when I just talk, and what I'm saying is not clear. Thank you for clearing that up for everyone, Manal. But I know she talked a lot. I have no idea what she was trying to say. So this one is in the geometry unit, and the topic is proportion applications in geometry. Turns out proportions come up a lot in geometry, and I got a ton of different examples in that lesson. All right. Well, you guys totally stuck it out with me through some pretty challenging stuff. I know there was some repetition, but like I said, they don't tend towards simple geometry problems on the GED. They like high depth of knowledge with a lot of reasoning and a lot of tricks. So thank you for putting up with my crap today. And you're super well prepared for your GED now if you followed that. Hopefully I'll see you next week when we review the data analysis that shows up on the GED. So what's data analysis? Well, I got good news. Data analysis is the math that scientists, mathematicians, and social scientists use, which means we're studying for 3 tests at once. So join me next week for that.